And process of converting AC into DC.
Okay, very good. Okay, anyone tell me what are the different types of rectifier?
Half wave and
half
full
wave
wave.
and full wave.
Yes,
Okay,
ma'am.
half wave and full wave.
Half wave rectifier and full wave rectifier.
Okay, so full wave rectifier is classified into different type. What are they? Full wave
Center
rectifier is
tap
and
bridge.
bridge FWR.
bridge. Okay, so what is off wave rectifier? Anyone? What is off wave rectifier?
मैम जिसमें कि वन साइकिल होती है एसी वोल्टेज की जो परफॉर्म करते हैं
What about
मतलब
other
वेव
students?
फॉर्म की वन साइकिल वेव फॉर्म की
मैम
पास होती
स्टेप डाउन ट्रांसफॉर्मर बनता है.
Okay, step down transformer मतलब क्या है खुशबू? Gushpu, tell me what is the function of the step down transformer? Why we are using here?
High voltage से low करता है. Low voltage.
High
Okay.
voltage पे.
Okay. So you guys know that what is the meaning of rectifier is? The rectifier is nothing but it is going to convert AC into the DC voltage. Okay. So rectifier में दो type है, half wave rectifier, full wave rectifier. So full wave rectifier, this operation is classified into two different type. One is center taps, again one is a bridge rectifier. Okay. So half wave rectifier means what? Whenever you are giving your input signal, okay, the input signal is a AC signal, that is alternating signal matlab example sine waveform. Okay, so whenever you are giving your input signal, if you are using a off wave rectifier, you will get output during the any one cycle. Okay, either positive cycle or negative cycle. So don't think that if it is of off wave rectifier means we will get positive off only. Okay, but here I have explained with the positive of, if you change the position of diode, okay, so the diode anode is connected to the transformer and cathode is connected to the load. If I change the position of diode, I will get output during the reverse bias condition. Okay, so off wave rectifier matlab you will get output during any one of the cycle, either positive off or negative off cycle. Okay, so ऑफ ए रेक्टिफायर सर्किट में क्या क्या यूज करने पड़ेगा? एक ट्रांसफार्मर यूज करने पड़ेगा. So what transformer we are using is step down transformer, then followed by we are using a diode. So you know the operation of diode. During forward bias, it act as a closed switch. During reverse bias, it will act as a open switch. Okay. So you know that during positive of cycle, diode will act as a forward bias. So the output is equal to input. So output is equal to input. So during positive of cycle, there will be a current flow. You know how it is, how the diode is act as a forward bias means, kyunki, so in the transformer input, we are applying the AC signal, right? So here I am using a step down transformer means it will reduce 230 volt to 6 volt. So if I apply the positive of cycle means, so positive of is connected to the anode means, that is positive is connected to positive means diode will act as a forward biasing. Diode is act as a forward biasing means closed switch, आपका output is equal to input. Okay, if you apply the KVL, you can get it. So the current flow is depends on the direction of diode. Okay, direction is side pay means the current flow also in this direction. Okay, it is in the clockwise direction. Minus to plus means आपका मिलेगी B in. Okay, minus. So here the output we are going to take that in the output we are going to take that is plus and minus. So plus 2 minus means minus a. So it's equal to 0. So V0 is equal to B in. Okay, so output voltage is equal to V in. Here I didn't consider the voltage across the diode. Here I am considering diode as a ideal diode. Ideal diode means whenever it is a forward biasing, there will be a current flow. We are not going for the practical diode. Here I have made an assumption. It is a ideal diode. So during negative cycle mein kya hua? Here I am going to apply a negative of means. So the input for the circuit is minus plus. So minus is connected to anode means it will act as a reverse bias. So open switch hai. So the current flow is equal to 0. Okay. So anyone tell me, so what is the output of off-air rectifier? What is the output of off-air rectifier? Rectifier का output क्या होना चाहिए बेटा? Anyone? Gunal, Mitul? Why the same students only answering for all the time? Arpit, Kishan, Gushbu. Mushkan and all. Some other students, please tell me what is the output of rectifier? बता दीजिए बेटा, please anyone? Rahul, Saksham, Sarthak. Anyone tell me what is the output of rectifier? Tisa. Anyone? Why no response from your side? Ayushi, Dhruv.
गिव्स आउट कांस्टेंट पोलैरिटी, या तो पॉजिटिव ही रहेगा या फिर नेगेटिव रहेगा.
ओके, सो आउटपुट में क्या मिलना चाहिए आपका रेक्टिफायर में?
मैम
रेक्टिफायर
जो
मतलब
इनपुट
क्या
देते
ये?
हैं वही आउटपुट
कन्वर्ट
मिलेगा।
एसी, नो, रेक्टिफायर मतलब क्या ये? एसी इनपुट देने पड़ेगा, आपका आउटपुट मिलेगी डीसी. ओके, बट वेदर वी आर गेटिंग प्योर डीसी इन द आउटपुट, दिस इज माय आउटपुट, राइट? वेदर वी आर गेटिंग प्योर डीसी?
नो मैम।
Nine. Okay, so that means the output of rectifier has not a pure DC, it has some AC component also. Okay, then I explained you the analysis of a rectifier. Already I told you koi bhi sine waveform means, so sine waveform is represented in the form of Vm into sine omega t. Vm matlab kya hai? Amplitude of the message signal. So omega t is nothing but the angular frequency of your message signal. Okay, so you know that if it is of current means we are going to represent it as Im into sine omega t, interval 0 to pi. So if it is of pi to 2 pi means there is no output voltage or current, so isliye 0. So last class I explained you how to measure the average load current. Okay, so मुझे मिलेगी the value of average DC load current is Im by pi. Then I explained you what is the meaning of root mean square value, how to measure the AC current also. Okay, so आपका IRMS you got Im by 2. Okay, so already I told you the rectifier means the AC to DC, but ideal case पे we are considering AC value is equal to 0, we are getting only the DC component. But practical case में आपका you are not getting a pure DC, there will be some AC component added with the input. Okay, so today we will see the other parameters also how to analyze the of a rectifier. Okay, so you have to at least know the value of DC current and RMS value. Okay, if it is of DC current means याद रख लीजिए the value is Im by 2. If it is of RMS value or AC, the value is Im by 2. Okay, so today we will see about another next parameter, that is nothing but a ripple factor. So shall I start?
Yes, ma'am.
Okay, so I have started recording also. So today we are going to measure the next parameter, that is nothing but a ripple factor. So what is the meaning of ripple factor? You have to know. Already I told you rectifier में आपका output क्या चाहिए? DC चाहिए, but you are getting a AC component also. So ripple factor मतलब क्या ये? So in the ripple using this ripple factor we are going to measure how much, okay, that is how much AC component present in the output. Okay, that is nothing but a ripple factor. So the definition is very very important one. Sometimes they will ask in your 2-mark question also, define ripple factor and write the ripple factor of a rectifier and full wave rectifier. Like this they can ask. Okay, ripple factor matlab kya hai? It is nothing but the percentage of AC content or AC component present in the output. Okay, so AC component present in the output. Okay, that is nothing but a ripple factor. So definition आप कैसे लिखना चाहिए? The ripple factor is defined as the percentage of AC component. That is, using a ripple factor, we are going to measure how much AC component is present in the output. So ripple factor मतलब क्या है? The percentage of AC component present in the output. Okay. So now we are going to measure the ripple factor. The ripple factor is denoted by the symbol R. So the ripple factor is denoted by the symbol R. So what is the formula for the ripple factor is? The ripple factor is equal to IAC divided by, that is IAC, ripple factor is defined as it is of IRMS, IAC of RMS divided by a IDC. Already I told you the RMS is nothing but a the component, that is the AC component added in the DC is nothing but a RMS value. So here we are going to measure I, that is the ripple factor is measured by means of IAC divided by the IDC value. So for this simplification, here I am going to write this IRMS value. Already I told you RMS matlab root means square value. Root means square value means what? The AC component added with a DC component is nothing but a, the DC component is nothing but a I square RMS value. Okay. So now I am going to write the I square AC value as I square AC is nothing but I square RMS minus I square DC. Okay. So IAC can be written as it is a root of I square RMS minus I square DC. Okay. So ripple factor ka, you know that. What is the use of ripple factor? Using this ripple factor parameter, we are going to measure how much EAC component added in the DC. So ripple factor का formula क्या है? IAC divided by a IDC. So सबसे पहले you have to write. I am going to find the numerator term, that is IAC value. So you know that RMS is nothing but root means square value. It is mainly used to represent the AC component present in the DC. That's why here I have written I square RMS is equal to IAC plus I square DC. So from this equation, I am going to write the value of IA square, IAC value. So IAC equal to, I am getting I square RMS minus I square DC value. So here you consider the ripple factor equation as the 1. Here consider it is here 2. So now you substitute the equation number 2 in 1. Equation number 2 in 1 means, so you will get R is equal to root of I square RMS minus I square DC. So you will get I square RMS minus I square DC divided by denominator term, just you put, that is IDC. Okay. So इसके बाद क्या करने पड़ेगा? For the simplification, I am going to write denominator term. So numerator term is in terms of square root. Okay, in order to do the simplification, I am going to write this IDC as I square DC whole power 1 by 2. Okay, so you know that a square into whole power 1 by 2 is nothing but a power 2 into 1 by 2. 2 cancel ho jayenge, you will get a only. Okay, in order to make a simplification, what I am going to do? I am going to write this IDC as I square DC whole power 1 by 2. Okay, so now I can write, okay, in denominator also I am having a root. So I can write I square RMS. I am just going to take common root for numerator and denominator term. So I will get I square DC. Okay. So now I am going to make a simplification. I can write I square RMS divided by I square DC minus I square DC by I square DC. So these two terms get cancelled. You will get 1. So you will get I square RMS divided by I square DC minus 1. Okay. Already we have obtained the value. We have calculated the value of IRMS value. Okay. So in the IRMS value is nothing but IM by 2. Already we have calculated. Similarly, we have already calculated the value of IDC. IDC is nothing but IM by 2. Abhi kya karne padega? You have to apply IDC IRMS value here. Okay. So already you know that IRMS value is where IRMS value is equal to, okay, the IRMS value is equal to IM by 2 and IDC is nothing but IM by pi. Abhi kya karne padega? You have to substitute these value in this ripple factor formula. So you will get I square M by 2 square divided by I square M by pi square minus 1. Okay. So just to do the simplification, here I square M है ऊपर नीचे, so दोनों कैंसिल कर लीजिए. So आपका मिलेगी pi square by 4 minus 1. Okay. Use the calci and simplify this one. Use the calculator and simplify this term. So you will get the ripple factor value, that is pi is equal to R is equal to 1.21. Okay. At last, finally, you will get the ripple factor value is equal to 1.21. Is it clear? Hello.
Yes, I'm clear.
Okay, so don't
Yes,
think
ma'am.
that you have, okay, don't think that this much derivation you have to derive in the exam. Okay, as a CSC student, mostly they are asking you to explain the working of the off-air rectifier. But at least you have to know in sometimes in 2 mark, they will ask you to write the ripple factor value for off-air rectifier, or sometimes they will ask you to, okay, just write a short notes on the rectification efficiency or ripple factor for the of a rectifier means you have to write this. At least if it is not possible for you to remember the derivation part, at least you should know the final value. That is ripple factor which obtained for the of a rectifier is 1.21. What is ripple factor? You have to know. Ripple factor is nothing but using a ripple factor, we are going to find how much AC component added in the output. Okay. So this is the third parameter. So the next parameter is nothing but a rectification efficiency. So anyone tell me what is the
मैं
meaning of efficiency?
1.1 क्या है मतलब
हाँ जी बेटा.
परसेंटेज?
So here we are getting
1.1
1.21 percentage value. If it is of percentage, you have to multiply with 100. Okay. So here the ripple factor value is 1.21. We are getting it for the off a rectifier. Okay. So how much percentage is added means here.
Ma'am, you are muted.
हेलो ये हेलो मैम.
Okay. एक minute. Sorry, sorry, beta. Sorry. Actually, my mic is muted. So here we are considering that that is how much value added is, that is 1.21 percentage of value added with the output. Okay. So next we are going to measure the efficiency. What is the meaning of efficiency? Generally, how we will measure the efficiency? Anyone? How we will measure the efficiency? Anyone tell me? How you will measure the efficiency of any system? Anyone? What is efficiency, beta? Anyone tell me what is efficiency?
Ma'am, input given to the system divided by
So
the
generally the efficiency is nothing but your output by input. Okay, generally how we will measure the efficiency? So how much output we got it for the input. Okay, so here we are going to measure the rectification efficiency. That is, in the rectifier the output is a DC only. Okay, so here we are going to measure the efficiency of the rectifier by means of the output DC power to the how much input AC power we have given. Okay, so next we are going to measure the rectification efficiency value. Okay, so in this rectification efficiency, already I told you. So if it is of efficiency, we are going to represent in terms of a percentage. That is, here I am going to measure in terms of a percentage only. So the rectification efficiency is denoted by the symbol N. Okay, the rectification efficiency is denoted by the symbol eta R. It is called as the N. So the rectification efficiency is nothing but it is the ratio of output DC power divided by output input AC power. Okay, you know that for the rectifier we are applying the input is the AC, output is nothing but a DC value. So the efficiency is measured by means of the power which got, that is output O represent the output DC power divided by the, here denominator we are having I represent the input power, that is input AC power. Okay, so generally you know that the power is represented by means of I square into, okay, R. Okay, so generally you know that the power, you know that in the physics you have studied, the power is represented by means of I square into R. Okay, so now I am going to write this output DC power as I square DC into, you know that the output is taken across the this value resistance RL. Okay, here I am considering that is RL. So similarly you have to write the input AC power as I square AC into RL. Okay, so here the RL will get cancelled. So you will get I square DC by I square AC. So already we have calculated the IDC value. The IDC value is nothing but IM by pi. Already you know that we have calculated the AC, that is nothing but IRMS value. You got IM by 2. Okay, अभी आप क्या करने पड़ेगा? You have to substitute the value here, that is I square M by pi, okay, divided by I square M by 2. Okay, so just you have to make a simplification. This I square will get cancelled. So here it is of I square, right? So here you will get pi square and 4 square. So here you will get 4 by pi. So already I told you we are going to represent in terms of percentage. So you have to multiply with the 100. So if you simplify this value, you will get 40.53 percentage. Okay, so the efficiency of a rectifier is 40.53 percentage. Okay, is it clear? Tell me, beta.
Yes, ma'am.
Okay, so shall
Yes,
I go to
ma'am.
the next one? Okay, shall I go to the next one? Okay, so the next one is nothing but we are going to measure the DC voltage. Okay, already we have measured the current, that is DC current and IRMS values and all. Next we are going to measure the average DC value. Okay, DC value is nothing but here, that is DC voltage value we are going to measure. Already we have measured the current value, that is IM by pi we got. Okay, next we are going to measure the DC voltage value. You know that Ohm's law. So in Ohm's law we are going to write V is equal to I into R. Okay, so that is VDC can be represented as IDC into RL. So already we have calculated the value of IDC. IDC is nothing but IM by pi. Okay, so here IM, what is the value of IM? You have to write. The IM is nothing but here, you know that generally the from the Ohm's law you can write I is nothing but is equal to B by R. So I can write it as here BM divided by R. Okay, here the R is nothing but in the of a rectifier we are having a winding here, primary winding and secondary winding here, then diodes are there. In here I am having a diode, then load resistance is there. Okay, so here the you know that Im is equal to Vm by R. So what is the value of R here is I am going to consider RL. RL is nothing but a load resistance plus then I am having a diode also. During positive off cycle, diode will conduct. So the diode, you know, already in the unit 1 you have studied about a diode resistance also. The diode resistance is nothing but a RF plus similarly, in the secondary winding, there will be some resistance that is nothing but a RS. Okay, so the RS is nothing but the resistance of the secondary winding. Okay, so the RF is nothing but the resistance of your PN junction diode during forward bias condition. The RL is nothing but your load resistance. Okay, so here I am going to consider this RL value is approximately equal to RL plus RF plus RS. So here I am going to write IM is nothing but the IM is equal to, okay, here I am going to write IM is equal to VM by RL. IM is equal to sir VM by RL. क्योंकि you know that the during the forward bias condition there is diode resistance value is very small only. Similarly, the value of RS is nothing but here the primary winding resistance. So here it is of here 6 volt or something. Okay, its resistance value also small. So I am going to consider this RL value is approximately equal to RS plus RF plus RS. That is, this value is negligible. These two values are negligible. So here I can substitute the ID is equal to IDC is nothing but IM by pi into RL. Already I told you what is the value of IM. I am getting IM is nothing but BM by RL into pi into RL. So these RL will get cancelled. So I will get the value VM by pi. So this is my VDC value. Okay, so now the VDC value is VM by pi. Okay, so very simple thing. In order to remember these value, you just you know that IDC value already I told you how to calculate. The IDC is nothing but remember the value IM by pi. If it is of VDC, its value is Vm by pi. Okay, if it is of AC current voltage, remember it is Im by pi. If it is of DC voltage, its value is Vm by pi. If it is of AC value, IAC means Im by 2. Okay, so next we are going to calculate here VAC. So VAC is nothing but your average voltage value. Okay, average AC voltage we are going to calculate next. Okay, so easily you can remember the value, no need to so I explained you the derivation also, how we are getting this value. Okay, so if you want, you can remember the derivation part. Otherwise, directly you can just directly you remember the final value. Okay, so next I
मैम
am going
RS
to calculate. Yes, beta, tell me.
RS क्या बताया था आपने RS?
RS is nothing but here the resistance of the secondary winding. You know that from the transformer only we are applying the input, right? So the RS is nothing but the resistance of the winding. That is, you know that the transformer has the resistance value, we are going to call it as, this is a primary winding. So this one is the secondary winding. So secondary winding ka resistance value, that is nothing but your RS. ठीक है बेटा अर्पित? अर्पित? Okay. So shall I proceed? Okay. So next we are going to measure the average AC voltage. Okay. So average AC voltage is nothing but VRMS equal to same thing only, IRMS into RL. Okay. Already we have calculated the IRMS value. The IRMS value is nothing but yeah, IM by 2. Okay. IM by 2. So you can easily remember why we are getting 2 only here. Okay. Because actually in the output we are not going to we are going to conduct a full off cycle, we will get only the off cycle only. So you can remember like this. Okay, that's why we are getting the Im by 2. Already I explained you why we are getting the Im by 2. Okay, this derivation part you can remember, but in case if it is not possible for uh, you to derive all the equation, means at least try to remember the final value. Okay, so next we are going to measure the value. So already you know that the value of IRMS is nothing but is equal to Im by 2. अभी क्या करने पड़ेगा? Substitute करने पड़ेगा. VRMS is equal to Im by 2 into RL. Already I told you, here I told you that Im is nothing but I can write it as Vm by RL. ठीक है, अभी क्या करना चाहिए? इधर substitute कर ली, you will get Vm by 2 RL into RL. So अभी RL cancel हो जाएंगी. So you have Vm. So this is my VRMS value. Okay. So next one is next term we are going to measure the peak inverse voltage. Peak inverse voltage, that is nothing but yeah, we can write it as PIV. The PIV is nothing but your peak inverse voltage. So generally the peak inverse voltage for the of a rectifier is equal to Vm. So what is the meaning of peak to peak value is, this is the peak value. You know that in a sine waveform, the peak value what we are considering is, that is your this peak value, that is a maximum value in a sine waveform is Vm. So it in the for the off a rectifier, okay, the peak inverse voltage value is equal to Vm. Okay, so that is the PIV value is very important one. So for the off a rectifier, the PIV value is equal to Vm. Okay, so the next parameter we are going to measure the transformer utilization factor. Okay, transformer utilization factor. Transformer utilization factor, that is nothing but TUF. Okay, so TUF. Okay, so the TUF, so the formula for the TUF is nothing but it is a DC. You know that in the rectifier, in the output we are getting a DC only. So that is nothing but the DC power delivered to the load. Delivered to the load. Here we are going to calculate in terms of your power. Okay, so DC power delivered to the load divided by the AC power. AC is the input power which we are giving, the AC power rating of the transformer. Okay, AC power rating of the transformer. Okay, so here I can write it as PDC. Okay, already I told you, it is a ratio of DC power delivered to the load divided by AC power rating of transformer. So we are going to measure in terms of a power only. So I can write it as PDC by PAC. Okay, so सबसे पहले you have to calculate the value of PDC. So PDC is nothing but power. I can write it as I square DC into RL. So already you know that IDC value क्या है? That is IM by pi. ओके अभी क्या करने पड़ेगा इधर सब्स्टिट्यूट कर लीजिए IM by pi होल स्क्वायर इंटू RL. सिमिलरली नेक्स्ट आप AC पावर रेटिंग का लिखने पड़ेगा दैट इज नथिंग बट DRMS इंटू IRMS वैल्यू. ओके so generally what is the meaning of VM? VM is nothing but your peak voltage. Okay, VM is nothing but your peak voltage. So the peak voltage is converted into the RMS value by means of dividing that value by root 2. Okay, so you have to divide that value by root 2 in order to convert the peak to peak voltage into the RMS value. You have to divide that value by root 2. Okay, so you will get VM by root 2 into IM by 2. So in the IRMS, here I am going to, already we have calculated the IRMS value, that is IM by 2. So just substitute here, you know that VM I can write it as IM into RL into IM divided by 2 into root 2. अभी क्या करने पड़ेगा TUF में substitute कर लीजिए. So it is my equation number 1. This is my equation number 2. So I will get I square M by pi into RL divided by here IM is there. So I can write it as I square M RL by 2 into root 2 value. So I square M RL cancel हो जाएंगी. I will get 0.825. Okay, so that is nothing but here the power delivered to the load we are calculating with respect to the AC power rating of the transformer. That is in the transformer input we are giving a AC. So how much output DC we are getting with respect to the AC. Okay, so these are the parameter. As your CSC students, they are not asking to derive this analysis parameter and all, but still you have to go through it once. Okay, it will be useful for you if they ask in 10 mark question, if they are asking you to derive all the equation means you have to. Okay, so same thing only, same procedure only. We are going to analyze these parameter for the full way rectifier also. Okay. So from this full way rectifier, actually, generally in the rectifier, we will get, we are not getting the pure DC. Okay, we are getting only the AC. Okay, but in your syllabus, you are not having that filter methods and all. If you are going for the filter, using that filter, we can remove the AC component, then we will get a DC. So what filter we are going to use is just we are going to use the capacitor to filter out the AC component to give the pure DC. But this topic is not in your syllabus. That is of a rectifier with filter, without filter. Okay, here you are studying only the without filter. If it is of with filter means after the output, you have to put one capacitor. Okay, after the diode, you have to put a capacitor. Then you have to use your load resistance to measure the values. Okay. This is the thing about your off a rectifier. Okay, so in the next class I will explain you the full way rectifier. Okay, so now listen carefully. So no need to worry about your derivation, ma'am. This much derivation is there. How to remember all the points? At least you try to remember the final value. Okay, it is not a that much difficult derivation. Also simple derivation only. If you understand the logic, then you can write it. Okay, beta. Hello.
Yes, ma'am.
Yes, ma'am.
Okay. Okay, so in today I will share you notes in the WhatsApp group. If anyone is not in the WhatsApp group, please ask the Kishan and ask him to add you in the group. Okay, so today I will share you the unit 2 notes. So please go through about your off rectifier and write it in your copy. Okay, okay, beta.
Yes, ma'am.
कोई
Okay,
दिक्कत नहीं
ma'am.
ना? Okay, so how many of you completed the unit 1? So please tell me. How many of you completed the unit 1?
मैम नोट्स बनाने वाली बात
ये लैपटॉप
No, no, notes nahi beta. Actually Actually, what I asked to you, I whether note my notes. No, I asked you go through the topic, right? बता दीजिए.
Yes, ma'am.
Yes,
Whether
ma'am.
I okay, whether I asked you that you just simply copy. No, I didn't ask you like this. Okay, I asked you to uh, read and then write. That means what? If you read means ठीक है वो वाला topic आप cover किया. That is the meaning of that one. Okay.
Yes, ma'am. Done.
ठीक है, done. Okay, so please try to complete the unit 1, so then it will be easy for you. By this week you can write the unit 2. Okay, so the main thing is you can ask me, ma'am, why we are going for these derivation and all. In this from this derivation, what we are calculating is we are calculating the ripple factor. From the ripple factor you comes to know that how much percentage of AC component added in the DC. Okay, that is the how much DC component, that is the percentage of AC component present in the output. Okay, so here we are getting the 1.21 in terms of percentage, means just multiply with 100 means you will get near to 21 and all. Okay, so by using this derivation we are going to measure the how much how much pure DC you are getting, how much AC component is added, how to remove that AC component. Okay, in order to, that is the use of performing this analysis. Okay, so please wait a minute. I will take the attendance. After that you can leave the class. Okay, so next class I will teach you the full way rectifier and bridge rectifier. For the full way rectifier, so same method only we are going to derive it. But the thing is, here we are considering, we are getting the output only during the positive of cycle. Okay, if it is a full way rectifier, we will get output during positive as well as the negative of cycle. So if you are getting output at the during positive as well as negative of cycle means, so in the same procedure only we are going to derive. But the thing is, here you can see, okay, here I have considered only IL is equal to Im sin omega t during the duration of 0 to pi. Okay, but in a full way rectifier, here I will get another Im sin omega t. This is minus I will get kyunki I will get output during both positive as well as negative. So positive as well as negative means in a full way rectifier during negative of cycle, I will get output in the positive side. So because of that one, there will be some phase shift in the output. That's why here I am putting minus Im. So क्या करने पड़ेगा, same derivation only, but इसमें here we have substituted that pi to 2 pi, here we substituted 0. Instead of 0, here we have to substitute the another one term. Okay, so next class we will see the derivation part. Okay, I will share you the notes today, so please go through it. Okay, in the next class I will explain you the remaining thing.